Just about every 2 years, the planet Mars makes its closest approach to Earth, around 36 million miles. That's when we pack our robotic emissaries off to the red planet, timing their launches to spend the least effort to get there. Some fly around it, snapping pictures. Others land to sample its surface. A few to crawl around its canyons and craters. These probes may pave the way for human explorers, and perhaps permanent settlers, who will dig deeper still in search of answers to our most pressing question. Did Mars develop far enough and stay that way long enough for life to arise? And if so, does anything live now within Mars' dusty plains? Beneath its ice caps? Or maybe somewhere underground? Mars does not give up its secrets easily. It's almost as if the little planet is embarrassed. Over a century ago, a few observers thought they saw clues that Mars is alive. In 1877, the Italian astronomer Giovanni Schiaparelli noted markings, which he saw as a latticework of lines. He called them canali in Italian, meaning nothing more than shallow channels in English. American astronomer Percival Lowell found the lure of these features irresistible. He saw Schiaparelli's channels as artificial canals. He speculated that they carried melting snow from the poles to the dry interior. After all, on Earth, the Suez Canal had recently opened to ship traffic. The Panama Canal was beginning to be dug. The Martian canals, Lowell said, were built by a sophisticated society confronting an environmental catastrophe on the grandest of scales. Those Martians, he thought, must face an urgent choice: move water across vast arid regions or perish on an increasingly dry planet. As the 19th century gave way to the 20th, Lowell took his case to the public in a series of best-selling books, and the public responded with questions. Who were these Martians who had the means to remake an entire planet? Some offered schemes for making contact. Giant mirrors would flash greetings, light beams, mental telepathy. Many astronomers grew deeply skeptical, but Lowell's vision of a harsh yet Earth-like planet endured in the public's imagination. That vision was dealt a harsh blow in 1964. The Mariner 4 spacecraft ventured in for a closer look, and what it saw looked like the moon. 3 more Mariners followed. They found huge dormant volcanoes, the deepest and longest canyon in the solar system, but not a trace of life, present or past. In the mid-1970s, 2 lander-orbiter robot teams named Viking took up residence on Mars. Maybe the Martians were just hiding, so the Vikings tested the soil for signs of life. But all the evidence from Viking told us Mars is not only barren, but in fact hostile to life. It's no wonder Martian air temperatures range from minus 20 degrees Fahrenheit to down below minus 200. It's also very, very dry. If all of the water vapor in Mars' thin atmosphere fell as snow, it would make a layer of frost not thicker than your fingernail. On Earth, impact craters erode over time from wind and water, and even volcanic activity. On Mars, they can linger for billions of years. But so can the imprint of riverbeds, lake bottoms, and ocean shorelines, and the Viking orbiters saw a lot of them. It's not hard to believe that a great deal of water once flowed here. But where did all the water go? To find out, scientists needed to do real field geology on Mars. They needed rovers. traveling robots with tools and instruments. In 2004, the heroic twin rovers, Spirit and Opportunity, bounced down and drove off, ready to roam the Red Planet. Opportunity had come to rest in a small crater at a spot called Meridiani Planum, and it didn't have far to travel. For here, in plain view, on the crater wall right before it, was exposed bedrock, the first ever seen on Mars. Not far away, Opportunity found layered rocks on the face of a cliff. On Earth, rocks like these typically form in sedimentary layers at the bottom of ancient oceans. And at every turn, Opportunity rolled across tiny, smooth, almost perfectly round pellets, called blueberries because they appear dark bluish-brown against Mars' rust-colored surface. Initially thought to be volcanic in origin, these blueberries proved to be iron-rich spherules of exactly the type formed within cavities at the bottom of an ocean. And the rovers had another trick up their mechanical sleeves. They could drill into the rock itself, brush it clean, and nuzzle a spectrometer right up to the virgin minerals. They found that up to 40% of the rocks were sulfate salt, a tracer for standing water, and that wasn't the only evidence. Spirit's broken wheel dragging behind it exposed soils saturated in salt. Clearly, these rocks had formed in water, but how long ago? And if you needed to find water on Mars right now, where would you look? One answer: the North Pole. From orbit, it seemed to be covered in frozen carbon dioxide, what we call dry ice. But might water exist below the surface? Enter Mars Phoenix, a lander that arrived near the North Pole in early 2008. Phoenix used rockets, not airbags, to touch down in what appears to be the floor of an ancient ocean. The lander's descent thrusters blew away the top layer of soil, and Phoenix snapped some pictures. It sure looked like ice. The mission's managers instructed the robot to conduct a simple experiment. Reach out, dig a trench, then watch what happens. As expected, clumps of white stuff appeared. A couple of days later, it was gone, vaporized. That means it can't be salt, or frozen carbon dioxide, which is stable in the cold, dry temperatures of the Martian pole. So it had to be water, the first ever directly seen on Mars. In fact, Phoenix probably saw droplets of liquid, salty water form and merge on its legs. And there are other indications that the North Pole was actually warm enough in the recent past for water to become liquid. Beginning in November of 2006, the Mars Reconnaissance Orbiter flew over the pole, sending out radar pulses to peer beneath the surface. These data have revealed that the ice cap, just over a mile thick, formed in a succession of layers as the climate alternated between warm and cold. Martian mood swings like this happen because the planet's spin is not stabilized by a massive moon like that of Earth. Mars can really wobble, with one pole tilting toward the sun for long periods. Whatever water's here now is tiny compared to what once was. There's a growing body of evidence that early in its history, Mars was on track to become positively Earth-like. But something went horribly wrong. Not long after its birth, the planet's molten interior welled up to spawn volcanoes and hot springs, spewing gas that formed an early atmosphere. As the atmosphere thickened, carbon dioxide began to trap heat from sunlight. In other words, the classic greenhouse effect. Temperatures rose high enough to allow liquid water to flow on the surface. What then caused these waterways to evaporate and the planet to grow cold and dry? In search of the answer, the Mars Global Surveyor spacecraft was brought down to a low altitude, and it made an intriguing detection. MGS documented the presence of a small magnetic field emanating from the planet. It's incredibly weak compared to that of Earth. Our magnetic field is generated by molten rock deep in Earth's core that rises and falls into a huge region below the outer crust called the mantle. That has turned our planet into an electric dynamo. The rising and sinking motion within, combined with the spinning motion of the planet, generates a strong magnetic field. This field is strong enough and extends far enough into space to deflect the wind of high-energy solar particles, protecting Earth and its atmosphere. In its early years, Mars too appears to have had a robust magnetic field. Rocks in some of the older craters bear a strong imprint of this field, while newer ones indicate a much weaker field. So what caused Mars' magnetic field to drain away, exposing the planet to solar winds? The answer lies in its violent past, a past that today is still written on the landscape. This is a simple elevation map of Mars' surface, from data gathered by the Mars Odyssey spacecraft. The South Pole, colored in orange and red, is piled high with ice that comes and goes with the seasons. Moving off these southern islands, we make our way north. The landscape is pocked with craters. The largest and oldest ones have slowly faded, softened by wind-blown dust. We now pass into the Tharsis region along the equator. Here, on a wide, high plateau, are a series of enormous volcanoes, including the largest one in our solar system, Olympus Mons. Just to the east is the great Valles Marineris. It's named for the Mariner 9 mission that found this vast gash in the Martian landscape. It's about 2,500 miles long and up to 400 miles wide. Dust devils sweep along the plains above it. And dust blows up the valley slopes. We can see this incredible landform in a realistic rendering of the data. Giant landslides have caused the walls to slump off and pile onto the valley floor. Feeding into this valley, a maze of side channels. Scientists think these and other tributary features were formed when water underground flowed into the main basin and the land above collapsed. Wider parts of the canyon are regarded as possible landing sites for human missions. They offer flat surfaces and possibly access to liquid water that may remain below the surface even today. From the layers of rock that line the canyon walls and layers of dust on the canyon floor, future science prospectors can fill in the details of the planet's history. The theory is that the great Valles Marineris formed early in Mars history as the planet cooled. Its huge sides were ripped apart as the Tharsis region, just to the west, began to rise up. But there seems to have been another, much larger event that changed Mars' course forever. Travel north, down the slopes of Mars' great volcanoes. The elevation drops as we dive into what appears to have been an immense ocean, with this vast basin in the north. And the very high elevations of the south, Mars is a lopsided planet. And here's why. Early on, when the solar system was young, Mars was apparently hit by at least 15 large asteroids. One of them was large enough to turn most of Mars' northern hemisphere into one huge impact feature. Earth too was walloped by objects this big, but because Mars is small, only about half the diameter of Earth, and has only about a third of Earth's surface area. The effect would have been much more profound and long-lasting. The thinking is that these impacts heated the outer subsurface layer of the planet, the mantle. That prevented molten rock in its core from rising up, and switched off Mars' magnetic field, probably forever. Without its electromagnetic deflector shield, solar radiation began to lash the planet, gradually stripping it of its atmosphere, and thus its blanket of warm air. What water Mars had would have vaporized into space, or frozen underground. Proof that Mars once had a thicker atmosphere may have landed, literally, in Opportunity's backyard. Just recently, the rover spied a strange bluish rock, a nickel-iron meteorite, sitting out on the surface. Streaking through a thin atmosphere, this massive chunk of metal should have made a much bigger dent. But a much more dense atmosphere would have slowed its fall and would have melted its exterior in just the way Opportunity now sees it. Now, there are a few competing theories that explain the disappearance of Mars' magnetic field and its atmosphere. What's certain is that at some point early in its history, the red planet grew increasingly desolate, and that the tragedy happened fairly quickly. The Martian landscape we see today is replete with coded signals from those early times: ancient riverbeds and lake bottoms, floodplains, and volcanic cones, as well as the clear battering it received from impacts. But is Mars a dead world? An infrared telescope on Hawaii's Mauna Kea volcano was trained on Mars over several years. Astronomers used a spectrometer to split the light into its individual wavelengths to identify chemical fingerprints in Mars' atmosphere. They found the signature of methane gas in amounts that change from place to place. Methane shouldn't last very long under Mars conditions. There must be some source that replenishes it. That source could be biological, perhaps microbes alive and well somewhere underground. Or the methane could be coming from volcanic activity, or maybe chemical reactions in Mars' crust. So far, neither satellites flying over Mars nor robots on the surface have turned up anything close to clear proof of living organisms. It may take the searching eyes, flexible minds, and nimble fingers of human explorers to find that buried treasure if it exists. In the meantime, we're finding that even if Mars appears dead, it's certainly not dull, though Mars has nowhere near the dynamism of Earth. With our oceans, turbulent atmosphere, volcanism, and shifting continents, Mars does do some fascinating things. If you take an atmosphere, however tenuous, add heat from the sun so it blows over the dry plains, you get the renowned dust devils of Mars. With no trees to hold down the soil, landslides are common. The Mars Reconnaissance Orbiter has returned images showing that Mars is actively remaking its surface. No, not in the canals built by the Martian engineers of Percival Lowell's imagination, but in picturesque sand dunes shaped by the wind, and in intricate landscapes molded by a gradually changing climate. Whether or not we ever find life forms on Mars, we can still marvel at the incredible beauty of its landforms, subtly sculpted over eons of time, on a world that never was.